Good day, everyone. Yeah, welcome to this math session. My name is Mr. Additional. So I will be taking you through binary operation. So before we move into the real deal, so we need to talk about some terms that you can come across, and because of dealing with the subjects, with the topics, rather. So I will start with this first one. All these things that we are going to be mentioning here, they are not something that is new, that you have not heard before. They are the numbers that we deal with in our everyday to-day activities. So the first one we are checking is the natural numbers. What are natural numbers? Natural numbers are numbers. They are a set of positive numbers that is used in counting and ordering. So natural numbers start from number 1. So number 1, number 2, 3, 4, and so on till infinity. So, and most times it is always represented by N, capital letter N, but it's not ordinary N. If you see something like this, see the N. But there's no way we can write this one because this one is a typed one. I want to say it naturally. We are writing it. Anytime you see a capital N, that is not normal. Something like this is a natural number. So the reason why we are treating this is because during the course of the binary operation, we may be measuring those terms, so it will not be new to us. So we have treated this under sets as well, because during sets, we may be given that we should write out the set of even numbers, set of odd numbers, set of natural numbers, set of real numbers, and so on like that. So this is natural numbers. So let's move to the next one, which is rational numbers. What are rational numbers? Rational number is the number that can be expressed as a ratio of two integers. That is, any number that you can write as a fraction, that's a rational number. When you have something like 2/4, you can see that this one is having a numerator, and denominator. So anytime you have a situation like this, that is a rational number. So any number that can be expressed as a fraction is a rational numbers. And in the course of the expression, we can see the expression here is written as m/n. So where n is not equal to 0, because when n is equal to 0, then the number will be 0. So that is that on rational numbers. Now let's move on to the next one. We have irrational numbers and the real number. Irrational number, the opposite of rational. Rational is a number that can be expressed as a fraction, while irrational numbers is a number. It's a real number that cannot be expressed as a fraction, cannot be expressed as a ratio of two integers. That is, it cannot be expressed as a fraction. So example of irrational numbers, we have done that in SOD. So when you have a number like this, a number like √2, √3, that's an irrational number. Then you have a pi. Pi 2 is an irrational number, though sometimes it may be represented as 22/7. But once it is being written as a decimal, 3.142, the number continues like that, it is very hard for you to return this decimal back to this fraction. So for rational number, you can easily convert a number from decimal back to fraction. So that is that on irrational number. Now let's move on to a real number. Real number is the mother of all number. So it is from real number that we have rational and irrational. It is from real number that we have all other numbers that we have. So irrational number is denoted by R. When you see something like this, R, that is irrational, and that is a real number, real number. So real number is represented as R, big R. Same thing as irrational. But rational numbers, as we have checked before, you can see rational number is denoted by Q, while irrational is denoted by R, and real number too is denoted by R. So sometimes to differentiate irrational from rational number, another number will be used for irrational number. So but that one is not unified. So real number in essence is the number that's all the number that are on the number line. And I believe you all know number line. This is the number line. When you have something like this, see 0, 1, 2, 3, 4. And on the other side there we have -1, -2, -3, and so on like that. So all these are real numbers. So set of all number on the number line. So from positive to the negative sides. That is that on real number. So now the last one, but not the least, is the whole number. What is a whole number? A whole number is part of natural numbers that includes 0. You know natural number does not include 0. Natural numbers start from 1, 2, 3 to infinity. But whole number start from 0. Whole number start from 0. So we have 0, 1, 2, 3, 4, and so on to infinity. So if I ask you to tell me the difference between a whole number and a natural number, you should be able to differentiate. Whole number includes 0, while natural number starts from 1. That is that on whole number. Now let's move to the main lesson now. All those ones that we did now is just to refresh our brain on some terms that you may come across. Now these are the learning objectives that we hope to achieve at the end of this lesson. So at the end of this lesson, we should be able to define binary operation, should be able to state closure property, commutative property, associative property, and distributive property. So we should be able to solve problems on all the properties that have been mentioned. Then we should also be able to identify the identity elements. We should be able to find the inverse under an operation. And also, we should be able to apply binary operation to real life problem. So, and you should also know how binary operation is being used in the real life situation. Because every aspect of mathematics that we are learning have its own application in the real life. Now, let's move on. So, key vocabulary words. What are those words that we may come across in the course of our teaching? The first one, we can come about the operation, binary, set, closure, commutative, associative, distributive, inverse, and the identity. So now let's move to the main topic now, binary operation. So what is binary operation? A binary operation on a set combines two elements to give another element of the same set. What's the meaning of this? Because this topic looks very simple, but you need to calm down and understand the concept. Once you understand the concept, it will be very easy. But if we don't understand the concept, we just feel like, what's this? What's the meaning of this thing we are doing in mathematics? What's the meaning of meaning? It has meaning. So it's a further math topic that has been included in mathematics. So we need to calm down to understand the concept. So when they said two operation, let's go by the word operation. So the operation in binary operation means some figures. So I will show you some of the figures that you may see as operation. So if you see something like this, they can use it as an operation. something like this can be used as an operation. Something like this, this is supposed to be a triangle, but in binary operation, you won't call it triangle. It has another meaning. It is an operation. So an operation can also be of this form. An operation can be of this form. An operation, just name it. It can be any form. So how is it being used? See the example we are giving here. A plus B on R. Who still remember the meaning of this R? R. R is real number. R is real number. And what are the set of real numbers? They are all the numbers on the number line. So A plus B on real number. That's an example. So let me give you a complete example how you can see the operation. Sometimes you may be given an operation like this. A operation B equals to A plus B. Anytime you are given an operation, the operation must be defined. So the operation is defining as A plus B. So if you want to perform anything on this operation like this, you may just be given two numbers. So since we have A operation B equals to A plus B, so assuming that you are not given a number like 2 operation 3, what will it be? Given that A operation B is A plus B, so what will be 2 operation 3? Fine. 2 operation 3 will be what? 2 plus 3. So just substitute the value of A and B into the definition that you are given here. It could be defined anyhow. This could be negative, this could be times. So, but you must work in accordance with what your operation is being defined as. So let's look at another example. So it said A times B on Z. Let me go back to this. A plus B on R means when you add A plus B, the number that you must get back must be a real number as well. So if 2 operation 3 is equal to 2 plus 3, what is 2 plus 3? 2 plus 3 is 5. 5 is also an element of R. Or 5 is not element of R. Element means 5 is also a real number. Is it not a real number? It's a real number. But we don't need that. I'm just explaining how those operations used to feature. So A times B on R. So that means the operation we are given is multiplication. Maybe they say A operation. Let me use another operation. A operation B is equal to A times B, or simply AB. So if you are given 2 operation, using circle, 2 operation 4, that will give us what? Since A operation B is A times B, so 2 operation 4 would be what? 2 times 4, which is equal to what? 8. That's how to define a binary operation. Hope you have copied that. Let's move on to the next slide. Now, these are the core properties of binary equation. So we are going to be treating each and every one of them one after the other. So we are going to treat closure. We are going to treat associativity, commutativity, identity elements, inverse. Let me just glance through from here for you. So closure, what closure means is that when you are given an operation, the elements, the answer that you are going to get after performing the operation on that number, the result you are going to get must also be element of a particular number you are given, or a particular set. We are going to understand that one better when we move to the next slide. But let me move to the associative parts. So I'm going to still explain this in other slides, but I want you to have the glimpse of what you are going to meet there. Associative means when you have three numbers or three elements. So we have X, Y, Z. So in associativity, when you have an operation, we can see that we have two operations here. One operation is between X and Y, another operation is between X and Y and Z. So for associativity property, we must have S operation, Y operation, Z. You can see that X operation, Y is being bracketed here first, and they leave Z at the back. Now, if you now interchange the arrangements such that you leave only X in front and bring your brackets to Y and Z. So if you now perform the operation on both of them and you still have the same results and the elements are still, look at this, for all X, Y, Z element of S. So you are given a set of numbers. So when you perform this operation, the result you get is still an element of that set. Now, the next one is commutativity. Commutativity means, that one is very simple. Commutative means A operation B is equal to B operation A. So just like when you have 2 times 3 is the same thing as 3 times 2. So whenever two operation is being performed on a number, on set of numbers, and when you interchange the number, the operations still work. So that is what is referred to as commutative. Set X operation Y equals to Y operation X. For all X and Y are still element of S. This S they are using here is the set of number we are given. So now depends on the set of number. You may be given set of real numbers, you may be given set of integers, you may be given set of whole number, and so on like that. So the next one is a identity element. What are identity elements? Identity element is just like the one we did in matrices. Identity elements. When you multiply a number by another number and you still get that same value. Let's say, for example, when you multiply 3 by 1, it will still give you 3. So this one is called an identity element. So when you multiply a number by another number and you still get that same number, so the number you multiply with is an identity element. So just like in the case of matrices, in matrices there's a number like this that we used to have. Okay, sorry, I have like this 1 1 0 0. So this is in matrix, this is an identity element, because if you use this to multiply any matrix, you still get the same value for that matrix. So also when you multiply any number by 1, you still get that value. So but it's not that this one is constant for all numbers. Like for addition now, when you have 3 plus 1, okay, so now 3 plus 1, 3 plus 0 is equal to 3. So it means for multiplication, the identity element for multiplication is 1, while the identity element for addition is 0. When you add 0 to any number, you get that number back. When you multiply 1 by any number, you get that number back. So that number that you are multiplying it to get that same number back is what is referred to as identity element. Why that of inverse? Have you all know inverse? What's the meaning of inverse? Inverse is the reciprocal of the number. When you have 2, the inverse of 2 is what? 1 over 2. So when you multiply a number by an inverse, you get an identity element. I don't know whether you understand what I'm saying. When you multiply a number, look at this. Inverse, for inverse, x operation y give us e, and that e is an identity element. The e is an identity element. So it's just like saying when you multiply 5 by 1 over 5. When you multiply 5 by 1 over 5, what do you get? 5 times 1 give us 5 over 5. That's what? 1. So now let's now move to the next slide, where I'm going to be explaining each of them one after the other, and we solve one or two examples on them. Now the first property is closure property. I promise you that I'm going to explain a closure property when we move to the next slide. So what is meant by closure? A set is closed. So as I was saying, closure property. A set is closed if applying the operation keeps you in that set. What's the meaning of this? When you are given two sets, like the example, I'll solve example like that in the former slide. When we have, let me give you an example now. When you have A operation B equals to A plus B, and you are given two numbers like this. Look at this example. Z is closed under addition. So when you are given 2 operation 5, it will give us, according to the definition of this operation, it's supposed to give us what? 2 plus 5. That is what? 7. Now we have been given a condition here. This is the set. The sets. What is the meaning of this Z? Z means set of integers. And what are integers? Integers are set of positive and negative whole numbers. Set of positive and negative whole numbers. So after we add 2 plus 3 and we have 7. 7 is also an element of an integer. 7 is also an element of an integer. So that means the set is closed. It is closed when, after applying the operation, the number that you get, the result that you get, is still a member of that set. So the set we are given here is integers. So, and the answer that we get here is 7. 7 is also an element of an integer. So, and it is not like this always for all operations that we have in mathematics. Now look at this second example. N is what? Natural numbers. And what are natural numbers? Natural numbers start from what? 1, 2, 3 to infinity. So now the example is now stating that natural numbers are not closed under subtraction. Let's check that. So what are natural numbers? I say natural numbers are numbers that start from what? 1, 2, 3, 4, and so on. Now, if you are using the formal operation that we have, that A operation B is equal to, A is equal to A minus B. Let's see, that's the operation. So, for this one to be closed, it means any number that we pick from a natural numbers and we perform this operation on it, the answer we must get must also be a natural number. So now, let's pick two numbers from natural numbers. 3 is the natural numbers. 5 is the natural number. Forget about what is in between them. So now, let's say we have 3 operation 5. 3 operation 5 according to this operation that we are given here. What? 3 My